This is experiment 6 for digital electronics 2. Here we have RE4. Or first here are our peripherals. We added timer 2 and PWM6. And then for pin module, we have RE4 as the output for PWM6. And then interrupt and system module, we did not change anything. For timer 2, we set the clock source to FOSC over 4, and then the post scaler to 1 to 16, and then our timer period is 16.34 milliseconds. If you go to PWM6, we have the timer as timer 2, and duty cycle is 50%, but that will change later since we will use the load duty cycle function. It says here that our PWM period is 1 millisecond and our frequency is 976 Hz. If we go to the code, here we initialize the PWM module, and then here we create an integer called duty and set it to 1, and then we increment it by a value of 10 per cycle until it reaches 512. So what this is doing is increasing the integer duty by 10 for each loop. And then here we are loading that duty value as we are loading that integer as the new duty value or the new duty cycle for PWM for the PWM output. So the PWM output has a value of 0 to 1023. So what this means, duty is less than 512, so the brightness will not exceed half of the maximum brightness of the LED. And what this will do is that the LED will get brighter since the duty cycle increases. And then this is just a timer for 500. It just waits for 500 cycles of this for loop before it continues, or before it continues the rest of this for loop. So here we have the circuit for experiment 6. The LED, which is the output, is connected to RA4, and then the VDD and VSS are connected to the positive and negative rails. So if we power this on, according to the code, what should happen is that the LED should slowly turn on to about 50% of its maximum brightness, and then it should cycle back to the lowest value, which is according to the it should cycle back to its lowest value. So here we see it slowly gets brighter, and then it gets dim, and then slowly gets brighter again, and then it continues that cycle endlessly as long as there's power.